get started here. Welcome back. I hope you had a good winter break as far as that goes, holidays and such. So this semester, what we're going to be going through, we're going to be covering Java, we're going to be working with Android, and we're going to be kind of using those together. I've got your tablets for you. I'll give them to you later in the week. I still got to factory reset them, but we'll be doing just Java for the first 2 weeks, so you won't need them until the 3rd week. So general overview of what's on the agenda for today. I'm kind of going to give you an outline of the course, of what we're covering and what materials we're going to be using, as well as going over some of our policies, procedures, looking at the syllabus, looking at the work ethic, grade sheet, and all those kind of things. We'll also need to get you set up on Perusal to make sure that you've joined the course there so you can read all the materials that I set up there and do the reading assignments. We'll go over kind of a brief history of Java and how that relates maybe to C# a little bit is in there as well, and also a little bit of the history of Android. Okay, we're not too deep there, but just enough to kind of understand some of those important things you'll need to know about. And then we'll get to our first program, our first Hello World program. We'll look at that. Once I've kind of shown you that, I've got instructions for you to install all your software and get that set up. I'll also look a little bit about the API documentation so you know where to find that, because honestly for Java's got some of the best documentation out there as far as any language is concerned. They're really, really solid, and you can thank Sun for that. But so I'll point you in the right direction for that, because that can be a little bit hard to navigate and maybe you haven't seen it yet. So overview of kind of where we're going this semester. So the first, it's kind of broken out mostly into 2-week blocks. So the first 2 weeks we're going to get into Java. And we're just going to talk about Java and writing console apps and such outside of the context of Android. So that's what we're going to do the first 2 weeks. In there, we'll use that quick syntax reference, which will be on Perusal. There's also a few other things on Perusal that are in your reading assignments. We'll look a little bit at the API docs. That's a good place to find references for some of the classes that you'll be using. There's a Code Academy course, which I've already assigned as a lab as well for Java, so you'll be going through that. And then there's also some problems that I've assigned on Code Wars, which again kind of gets you into algorithmic kind of problems and stuff. Those are typical interview questions. Once we finish up that first 2 weeks, the next 8 weeks, we're going to be going through an Android textbook that was produced by Google. It's kind of their, I think they call it Android Developer Fundamentals. So we'll be going through that on Perusal. I've uploaded all 4 of those PDFs already, and that's where you'll end up reading them, is on Perusal. But those are free. That's all free. So once we finish up that textbook, we'll go look at Volley for about a week, which is an API. It's kind of a library that Google has produced for working with web APIs. The Ajax kind of stuff that we did last semester, but doing it through an Android app. So it's going to take JSON down and do the logic with that. The next thing we'll look in there for about a week is a little bit more about how do you write apps with more than one screen. And this textbook may touch on that a little bit, but there's more than likely there'll be a little bit more that we need to expound on about how does that work. And then the last topic that we'll get into is looking at Firebase, which is kind of a popular system that's out there, again, by Google, that they put out there to kind of manage users and data, and it helps kind of synchronizing things automatically between a bunch of different devices. So we'll look a little bit about that. I'm not too familiar with Firebase, so I'll have to kind of read up on that. But we're going to spend a little bit on a week on there. We won't go too deep.
Are we using relational databases?
We may get into SQLite a little bit. It's kind of a catch. So from everything that I've seen as far as dealing with data, right? You've got a few different options for dealing with data. So SQLite has been kind of the traditional way of storing data on a phone. So it's a small SQL database that's stored on a phone. That's becoming a little bit less popular, especially given that it doesn't allow you to share that data then with other devices. So it's only on that device. So using a web service, things like that, you can have data that's on a central website that's then shared and used by all of your website, as well as used by any apps you do, right? Whether you're writing an Android app or an iPhone app, they can all use those web services. So that's kind of the more common way nowadays to store data, is you end up storing it on the website's database instead of storing it on the device locally. Unit 4 is called saving user data, so there's a little bit of other options in there of how to manage data that we'll go through there, but the relational database side is maybe not as big of a deal this semester. Does that make sense?
Yeah.
Because there's a lot of other tools that we'll be exploring. But we may touch on SQLite a little bit when we get to Unit 4. And Firebase is another way to store it entirely. So, and then we'll have the final project. Once we finish all that, you'll have about 2 weeks for that. This is give or take a little bit because things always change. So add a day, subtract a day, different places as that goes on. But that's the general overview of where we're kind of going to be going. So the main thing is the quick syntax reference is what we're going to go over in this next week or two. And then we'll have this Android textbook for the next 8 weeks. And then we'll have some other stuff after that. Okay. So let me pull up the syllabus. And we can go through that next. Okay. So 203, you've already found the room. Our meeting time is 12:35 to 4:25. Just a reminder, leaving early, getting in late, all of that. If you're packing up, make sure you're packing up at 4:25. If you're packing up before 4:25, that's already counted as leaving early. And yeah, 80 sessions this semester, and we'll be in the G203. You've got my contact information here. That's my school email. This is my personal cell phone. I'm usually pretty quick on texts as far as that goes. Usually a lot quicker on text than email, to be honest. So, program level outcomes, as far as how this fits in, our general program level outcomes are develop and design websites, latest version, yada yada, develop and troubleshoot applications using object-oriented programming practices. So we won't be doing too much website development, if any, this semester, but we'll be hitting pretty strongly on that. We will be hitting on that second bullet of object-oriented programming because Java is entirely object-oriented. There's a lot of object-oriented stuff you have to do with Android. Data-driven, not so much. We'll still be doing version control. So the main one where this fits in is that second bullet of stuff that we're going to hit this semester. But there's also a lot of GUI stuff because Android is a very different system how you set up UIs. So you'll be seeing a very different kind of setup. We'll see a lot more with UIs this semester as well. Official course textbooks here. We kind of looked at this. So we've got the quick syntax reference, which will be on perusal. We've got the Muroc textbook. We won't actually be using the Muroc textbook this semester. We'll be using that Google textbook instead. General outcomes for this semester. Develop Android apps that respond to events in Android Studio. So, hey, doing normal GUI development where you put a control on there, or as we might say, a widget, and then respond to when you click buttons and do different things. We'll look at some of those different controls, the edit, the text view, the edit text, the button, the image view, spinner, recycle view, all of those in there. And then looking at multiple screens, looking at theming, styling, some of these other files that go into making your website configurable and adjust to different screen dimensions. So, general student handbook rules apply here. You can look those up on your time. IT department specific policies, just to remind you, no streaming videos unless it's for class. So whether that be YouTube or sports channels or whatever it be, if it's not for class, then I don't want to see it in. If it's not for class, don't watch it in class. That includes during breaks. So if you want to watch something that's not class related during a break, please step out. So it's not distracting anybody who wants to work. Cell phones allowed, but again, make sure that you're only doing class related stuff on that. Okay. Earbuds are okay, no over the head earphones as far as listening to music and such goes. The limit of absences for this, oh no, so sorry, this course goes up to, there it is, seated and absent. So for this course, there's a total of 6 absences. If you get past 6 absences, that 7th absence, you'll be automatically dropped from the course. There is a way to appeal that and to stay in, which will, if you were to get into that situation, I'll walk you through what that process is. But there's a form you have to fill out, and then that gets turned in and approved or denied. But if you do get up to 5 absences, that is 5 absences or more is an automatic needs improvement. Doesn't matter what else you've done, it's going to be a needs improvement at best. Okay. Make sure you're wearing dress shoes, no tennis shoes, no, tennis shoes, and no athletic shoes. Business appropriate dress socks. No jewelry. I don't think that will be much of a problem. No hooded garments. That's the big one to remember. So that one is not specific to the entire college, but that's an IT department specific one. And just to clarify, that rule applies as soon as you step in the classroom. So take it off before you step in the classroom. You know, whether you've got a coat or anything. If it's got a hood, take it off before you come in. Okay. Attendance rules are the same as last year. Up to 6 is the cap, and being either 10 minutes late or 10 minutes early, that's the line where it's tardy. Anything more than that is an absence. As far as making up work, that's generally an option if there's, especially if there's extenuating circumstances. So should you need to make up a hands-on test or a written test, please get with me if you're not going to be there that day, or if you need to make it up afterward. But we'll do that by appointment. Academic honesty, let me be really clear, I care about this a lot because is a really big deal. And if I do catch you on with that, that is automatic 0 on the assignment. And yeah, and also put you out at automatic work of DNM, of does not meet. So I don't want to see any of that. And let me be real clear about that. That means no collaboration, right? So if you're working on whether it be a design document or code or whatnot, that's an individual assignment, right? It's okay to be looking over, to go help somebody with their code and whatnot, but there's a line between telling them to write this and write that and write that and giving them, ideas. If you're going to be, the safe way to go about it is look at what the application is doing without looking at the code. That's always a general safe thing. Say, well, okay, that's how it's behaving. It looks like your problem's probably here, right? If you see the error message, this error message says that. But there's a definite fine line of like, hey, my code, yours code. And one of the things we talked about last semester, looking at somebody else's code to say, check that you're both right, that's not okay. You need to develop your own skill to say, is my code correct? Because you will need to do that in the industry of being able to check and test your own code. Okay. So the way the grade breaks down, homework will be about 10% of your grade. You'll have a homework assignment roughly every week to turn in. Written tests are 20% of your grade. Both of those are kind of the theory portion of your grade. So that's about 30%. Okay. And the rest of that is where we look at the hands-on stuff. So you've got lab assignments and you've got hands-on tests, you've got final project. Labs are 20%, hands-on tests are 40, final project is 10%. So that's how that all breaks out. Labs expect probably a lab assignment every 1 or 2 weeks. When we get to that textbook, most of your lab assignments will be at the end of the end of sections. So there's a lot of built-in kind of assignments into that textbook, which we'll be doing. Your written tests and your homework, those are all be on Inside Rankin for the most part. Your reading assignments on perusal will come into that 10% homework. So we'll talk about that when we get to setting you up on perusal. But basically, I'll be expecting you to do some annotations on a weekly basis in perusal. Okay, grading rubric, as you're familiar with. As far as workload goes, my general expectation, to just be clear, is at least 2 hours a day outside of class for every day we have in class, right? So we have 4 hours in class. You're going to need to be spending at least 2, whether it be reading or working on lab material every day. So 10 hours a week out of class. So that's as the bare minimum, right? Some weeks it may be more than that. Okay, is that clear? But 10 hours a week is recognized that's your bare minimum expectation. Okay. As far as late work, again, I do take late work, but it's up to 5 class days. Every class day it's late is minus 10%. If it's not submitted, if it's not committed and pushed to get, it's not been turned in. So we'll still be a late penalty on that. So make sure that you're submitting that on a regular basis. And the big thing, make sure you're submitting on a daily basis, because here's the thing. I'm usually pretty lenient about that if you're submitting on a daily basis, right? If you're only submitting every 2 weeks, I'm going to be much more hard on that. Does that make sense? Simply because if you're submitting every day, I can go look at where you are and grade based on your previous turn-in. That makes sense? If you haven't submitted for 2 weeks, I've got nothing to grade, which means I have to come back in another 2 days to grade specifically your assignment, right? So that eats in my time to prepare for other things in class. So make sure you're submitting on a daily basis. That's also important as far as you're working with other people in the workforce. You know, if you're sitting there with code on your computer for 2 weeks that hasn't been pushed, right? That's code that nobody else has. And it also means that there's 2 weeks of changes that all your whole team has made that you don't have, right? So if you wait 2 weeks to submit, you're going to find that none of your code works and all of your code breaks everybody else's code. So you really have to be submitting on a regular basis, right? And the general good rule of thumb is actually about 3 times a day. That's really your target. Every time you finish a major piece of functionality, put it in, right? As soon as you get it working, put it in. Don't wait for the entire assignment to be done. Put it in once you've got something working. Because the other thing that happens there, remember, every time you remember in Git, it's got this track of your version history, right? So you can always go back to a previous commit, right? So if you make small commits here, it's easy to see what did you change, why did you change it, and go back and say, oh, well, I screwed something up here, and it's a lot easier to see where you went wrong. Or go back and say, hey, I need to see where did I do this, okay? So there's a lot of benefits with doing smaller and more frequent commits. There's general college information there, and that's basically the end of the syllabus there. Any questions, syllabus-wise? Let's go back here. So your work ethic, I don't think I've set those up on the on Inside Rankin yet, but there'll be assignment there for every 20 days. So we'll have 4 assignments total, and it'll be an average of that. So I'll grade you 4 times this semester. The rubric for this, the grade sheet for this, is on the main page under handouts. And take a quick look at it so you know what it looks like. So each category is graded on a scale of 0 to 3. So 0 being negatively observed, 1 not observed, 2 positively observed 1 time, 3 positively observed multiple times. Okay, so that's where that breaks up. So each of the five categories, we'll add those up. That's what gives you your score, right? So an average, there's also ranges here, so that sum, if that sum is between 13 and 15, that puts you as an exceeds. If it's 9 to 12, that's meet. 4 to 8 is not, needs improvement. 0 to 3 does not meet. So that's how I'm calculating that. Okay, and we can see for each of the different points, there's different bullets that factor into that. So for exhibits, pride, and performance, uses time effectively, takes personal satisfaction in a job well done, self-motivation, goal-oriented, dedicated. That generally, the biggest way that I measure that is with the quality of your code, right? How good quality is your code that you're turning into me, okay? If it's generally low quality, that's going to be a lower number on there. If it's generally above average, that's where it's going to be a higher number on there. That makes sense?
So does that one just reflect your grade pretty much?
No, for sure. Because I'm looking at the stuff that you have turned in, right? Because your grade also reflects how much of your work have you turned in, right? So you could still have a high point in exhibits performance if the grade that you turn in is consistently high, even if it's not all of the work being done. That make sense?
Yeah.
That's the difference. So usually that's where I measure that is how good is your code? Do you leave comments? Do you give good variable names? You know, do you pick good data types? All those kind of things is usually the biggest thing that influences that score. Okay. Just signs that mainly signs that you're, you know, taking the time to improve yourself and make the code better. Okay. Ability to get along with others, you know, that stuff I pay attention to, how you interact with other people in class, you know, and I do strongly recommend people don't be islands, you know, interact with people in the class, don't keep too much to yourself. There is value in asking for help. Don't feel bad about asking for help, okay? Because that's something that really happens. There are times where you need to go focus and put your head down on a particular problem and get it done, but there will be plenty of times where you need to talk to somebody else on the team and work through it together. So don't be afraid of doing that, okay? But I don't want plagiarism to come out of it, okay? Because just because you're looking at somebody else's screen doesn't mean that you both see eye to eye on how to do it, so you should end up with still different outcomes. The program you build should be different. Okay. Positive attitude, a lot of that comes through your interactions with me. A lot of that will come through just reading attitudes and where are you at with that. That's mainly where that comes up. Respect for workplace authority. Treat me as your boss. That's the biggest thing I would say on there. You know, from the grading point on that, you know, treat me as your boss. If you would not do that with your boss, then don't talk that way with me, right? Because basically we're setting the rules here, and that's what that is. Make sense? Also in there comes your attendance, appearance standards, all those kind of things. That comes under workplace structure. Okay. Honesty, pretty much that's going to be a 2 or 1 or a 2. See, what was the thing on there? Yeah, pretty much I grade that consistently a 1 or a 2. throughout unless there's some cheating involved. That's basically what it is. Don't cheat. If you do cheat, that's an automatic 0 in there. Okay. Attendance record, worth that good violation. So does that make sense as far as how that rubric's laid out? Okay. So let's go back to presentation here. So that's looking at the work ethic. It's also worth noting the appearance standards, because you know Rankin has an appearance standard that you're expected to follow. The place that you can find that is in because it has changed over time. It's in the student handbook. You can find that on Inside Rankin. If you just scroll down, it's right here. So it's on page 23 to 24. Starting towards the middle of the page. Okay, so looking at that briefly. Okay, so general prop for heron earrings. Rankin Technical College embraces diversity and realizes that students must conform. Students enjoy wearing different hairstyles. However, one of the employability skills that employers have asked to emphasize is in concern with individual appearance. I keep jumping. Personal hygiene, grooming. So there are some standards as far as what you need to obey. Okay. So as a general rule, hair needs to be clean, trimmed, neatly groomed. Okay. I don't mean to call anybody out, but Alex, you need to fix that.
Okay, like a haircut.
Your beard's fine, your hair is not. Hair, it doesn't necessarily be cut, but it does need to be groomed. Okay, I would currently consider it not groomed. Okay, does that make sense?
Yeah.
You may need to get it trimmed, but it definitely needs to be groomed. Okay, I think everybody else is good on the hair department. Beards are okay. The one thing that we ask is that if you have a beard at the beginning of the semester, if you have a beard today, keep it. If you don't have a beard, don't grow one. Simple as that. You know, shave every day. If you have a beard, you're simply shaving every day. If you do not have a beard, simply shave every day. If you do have a beard, you're still going to need to groom it on a daily basis. Okay? Beard trimmer or such. Okay. That's basically what goes there. Earrings, I don't think we'll have a problem. Hats, just don't wear hats on campus, and you'll be good. If you are going to wear a winter hat, just take it off outside of class. Simple as that. Okay. Yeah, and we covered facial hair. So that's the main thing. As far as shirts, make sure you're wearing your Rankin approved shirt. Make sure you're wearing slacks. Make sure you're wearing dress shoes as far as your shoes are concerned. Outer garments. Again, the biggest thing for outer garments is just the no hoods rule. Otherwise you're fine. Please do make sure you take your winter coats off when you get in. Any other questions, appearance-wise? Okay. Do you remember belts are required with your slacks? So make sure you're wearing a belt every day, and your badge is part of the appearance code. So at this point, I want to get you set up with Perusal. You're going to follow the link. Just go to perusal.com and use that course code to sign up. Because that's where all your reading assignments will be this semester. Yeah, please use your school email in there if you could. Well, you can use your personal. Yeah, use your personal. Use your personal. To me it doesn't matter because all it shows when you get in there is your name, your full name. So I don't really care which email you use.
No, oh wait, this semester. No, they'll eventually go away.
Yeah, eventually we go away when we graduate.
I think last
But yeah, isn't
year-
perusal just like this like a this semester thing? Like would we have a need for it? That's where the book is. Okay.
Yeah, if you wanted to keep the textbook, that's where it is. But so all of your reading assignments will be there. The reason that we're using this, again, this is kind of something I learned about last semester from a math teacher that's been using this for college level classes, encourage reading. So there's a lot of tools in here to do kind of collaborative reading sort of thing effectively. So you can open up the PDFs that I've uploaded or the textbook, and you can kind of highlight and put a comment on it and start a discussion. So there's a few things already on the textbook that have already put a few annotations in there.
So when you say annotations, we're gonna have an opportunity like to take notes and stuff. Is that what you're saying?
Let me kind of bring this up and we can look at. Let me open up the textbook and I can show you what I mean by that. So just to walk through, maybe I need to walk through. Once you get logged in, you'll probably be on this getting started page once you get into the course. But there's a few different tabs. This is under course home. If you go to documents or assignments, you should have either of those. So documents is the list of all the files that I've uploaded. There's a number here, so I have different folders to kind of organize things. A lot of the stuff that you'll want right now is under the Java folder. So that will be where most things are, as well as the Java syntax reference. So there's documents and then assignments, and that's where you'll get to see the due dates on the different reading assignments is under this assignments tab. So whether you start from assignments or documents, you can click on here and say open. And that will bring you into this view. There's a few different things on the side here. So the big one you want to get to is table of contents, and that way you can kind of jump through the document. The other thing you may want to do to change the size of it, there's a little zoom button up here, and you may want to zoom that in or zoom that out, depending on what makes sense for you. Okay. Now, what I have seen is that zoom behaves differently on a PDF than it does on this textbook because it's reflowable text. So you'll see a little bit of different behavior as you're reading through the syntax reference versus all the other PDFs.
We need to go ahead and buy that book.
Huh?
We need to go ahead, like all of us got taken to the build page.
You said what?
Like we're all on the building page. So we need to go ahead and buy that.
So I believe that you have to pay for the book.
Yeah, that's what we talked about. So you also $20 wasn't really a problem.
Yeah, that's what I asked about. So yeah, you have to pay for the book before you can fully get in there. But for right now, you don't necessarily need to do anything on that system right now. You need to do stuff this week because there's reading assignments. But right now, I'm just trying to walk you through where things are. But yeah, you will need to do that this week at some point. So zoom's up there. You can get to contents. If I go to, let me get out of here. So let me scroll down and get to past the table of contents. Where's the first? Oh, there it is. So if you go to these, so this says all conversations, and you can jump to and see all of the different annotations that have been put in there so far. Where's that first annotation I put in? There. So as you're going through, you may see Why did it jump to a different page? So as you're going through, you may see things like this where it looks highlighted. If you click on that, that will then take you to the thread on that line of different conversations that's been had. So you can put comments on it. You can have discussions, questions. So if you have a question on something in the textbook, you just highlight that part. You have a question on it, and write up your question, and I'll get it and I'll review it. And then I can give you an answer. Or somebody else in the class can give you an answer.
So do you get notified for every single annotation? Or do you...
Mm-hmm.
Okay.
Yep. So I'll get in here. I'll get all they have a way to easily get all the comments and all the questions, anything like that. So basically, your assignment's going to be on a weekly basis to put at least one annotation on the assignments.
So say if I highlight something, are you going to be able to see that? You're going to be able to see that?
Well, I only be able to see it if you put a comment there, right? If you highlight it and then put text, right? So if I just highlight this, it doesn't save it until you type something in. Does that make sense? So it's not going to save it until you write in a comment or something like that. I think that I forget. I think there's a way to mark something as a question. I don't see it offhand here. So you'll see a bunch of annotations in there that I've already put in on things that are, hey, by the way, you may want to know this, or there's a few things that are maybe corrections on. There are a few typos in the book as well. So I put notes on some of those things as well. Yeah.
Is perusal can only be used in the web browser, or is there like a desktop application?
There isn't a desktop application. I have used it on a phone, and it does appear to be mobile friendly.
Yeah.
So you should be able to get in. I was able to get in and read these books on a phone.
I don't see your annotations.
Can I see? Go to chapter 5 about snows.
Oh, wait, now they're showing.
Yeah.
Maybe because I got it on.
Yeah. So the all is not showing. Seems to be only showing the ones for that chapter. I didn't see that. Yeah. So that's the gist of it. There is a bunch of different metrics that it does record. It records how long you've been on a particular page and things like that. It records how long you've been reading the book and how many of those pages you read. So there is some stuff that factors in as far as automated grading that it does there. It also does there's a little bit of AI on the comments, on your annotations, about grading their quality. More than likely I'll be coming in and grading them manually, just because it's not always obvious what's a good comment, what's a bad comment. But all I'm looking for basically on a weekly basis is for each of these assigned documents to put in at least one. As long as you put in one good comment, that's full credit. Does that make sense? That's it. So that can be a question, that can be a pointing something out in there, that can be finding a typo, whatever that may be. Does that make sense? And again, you'll kind of see that there's a thread structure here. So once somebody posts one comment, then you can reply. So there's actually a conversation that happens on those, not just a single like, hey, here. Okay. Any questions further on perusal at the moment? I'm sure there'll be more as you get into it in the upcoming weeks. But at least that'll get you started. The biggest thing to start with is once you buy the textbook and get in, you'll want to go into assignments, and you'll see that these are the 3 that are currently due by Friday. Is reading through, sorry, not this Friday, next Friday. The quick syntax reference, there's this commonly used Java classes that I posted up there. I'll talk about that in a minute. And then there's also a PDF that I pulled from Code Academy in there as well.
So the assignment is just to do a comment on each of those.
Yep. Read through it, put at least one good comment. That's all you need for credit. So that's perusal. Before I leave that real quick, let me check that everybody's in the course.
You want one on each section or just the entire document?
Anywhere in the document.
Okay.
Anywhere in the document. One good one, anywhere in the document. So let's see. So Brandon, check. Eston, you're in. Ben, you've created an account. Alex, there. Evan, Graham, Dalton. Okay, so everybody's got an account on the system. Good.
So when you close out and come back in, does it say where you are?
Yes. Well, I don't remember. Actually, no, I don't remember. I think it does.
There are no page numbers. There's only one page per section.
Yeah, most of those are one page per section. If you go into, let me open up one of the PDFs. So if I go to documents,
Is there like a download of the PDF, or do you have to view it?
you'll need to view it on here. Partly just because then it captures the metrics. If you were to say download the PDF and read it offline, it won't have those metrics or grading. Does that make sense? So it grades those as you have it open and as you're reading through it. So in here, let's say I look at this PDF. The page number's up here in the PDFs.
I'm looking at that, the syntax reference then.
Yeah.
So when you're into the table of contents, you can click the page number, and it will take you to that page.
It should, although I did have an issue this morning when I was playing with it, that when I clicked from the table of contents that it didn't there. So it did remember where I was and jump back to it. But
Wait, so is this a different book than what you were at before? The quick syntax reference?
no, I'm in the same, yes, it's the same one.
Oh.
I have had an issue today. I hadn't had this issue until today, but I have had the issue today that sometimes when I go through the table of contents, that it doesn't, that it takes a very long time to load. Sometimes. But yeah, in theory, if you click on, say I click on chapter 13 here from the table of contents, then it does take me there. So, page numbers. This particular one doesn't have page numbers, but yeah, it's set up by sections. All the other PDFs will have page numbers. This textbook doesn't have page numbers, but the PDFs do. So, like if I open up this one, which is Unit 1 of the Android textbook, you'll see page numbers as you go through. Like they're down at the bottom, and they're also up here in the toolbar. So we've talked about rules, procedures. We want to look a little bit about the history of Java. But before we do, let's go ahead and take our first break. And if you would, please come back at 1:35. Okay, so we covered kind of classroom roles up to this point is the big thing we've talked about, and we've gotten you set up on perusal. And I don't want to be at that slide. I want to be there. So the next thing we want to talk about is some of the history of Java and some of the history of Android, because it is important to know some of these things, especially as you're looking at the documentation. Okay, and even as you're reading through the quick syntax, you'll see a few of these things where I talk about what version of Android certain things are introduced in, or Java, because it's worth knowing for a lot of different reasons. So to walk back and maybe talk about origins of where does Java even come from, origins of the language, that's worth, there's a few things that are worth knowing. So if we go back in time, 1972 is when C originally came out. Okay, so it was written originally in 1972 by AT&T Bell Labs, who originally created C. Okay. And the reason we care about that is because C is kind of the progenitor to both C# and to Java. Okay, there's a lot of things that in both of these languages that we can trace back to C. And along the way, part of the reasons that that's also important is as things went on, there was a lot of intent and intentional decisions in the language to keep what the previous language had done, keep a similar syntax. There are some places where different languages have diverged and done things very differently. But there's a lot of things, if you compare modern Java with C, you still find a lot of things in common. Okay, not everything, but there are still a lot of things in common. So C came out originally in 1972. C++ is then in 1985. And C++ is where we first saw object-oriented programming. So there were some languages that came before C++ that had object-oriented programming, but this is the first one really where it gets into the C family. So C was not, there were no objects. There were no classes. It was all functions and variables and lines of code, right? But you didn't actually have objects. Now, that being said, we had something called a struct, which a struct was our own custom data type. You could just stack things together and say, I want a point. Well, it has an integer x and an integer y. I'll call it my struct, my point struct. And that's what it has. It just has two variables, one for an x coordinate, one for y. It doesn't have any methods. It doesn't have a constructor, none of those kind of things. It's just a way, it's just my own custom data type. So C++ built onto that, and that's where we start getting things like constructors and subclasses and inheritance and polymorphism and all those kind of things. We also see in both C++ and C, what we have is explicitly managed memory. There's no garbage collection yet in either of those languages, right? So if I say create a new object, I have to then delete it. I have to free up that memory once I'm done with it. If I don't remember to do that, it just sits out there and it's memory that's still in use. I have to remember to do that. Okay, so that's one of the things come Java in 1996. One of the things that they first introduced there is this idea of garbage collection, where you create the object and then the system will automatically figure out when to throw it away. Okay, now there's some stipulations around that, but basically what happens is once you stop referencing that object, once it starts any variable, once there's no variables that have access to that object, well, it'll go away effectively when it can. It gets put into the heap and it says eventually when it gets around to it, it's going to throw it away. So that's one of the big things that Java kind of put in place. The other thing that happened is C++ is a very difficult language for a lot of reasons. And one of those reasons is there's a lot of ways in Java to really shoot yourself in the foot and shoot yourself hard, especially because of one thing we have in C, both in C and C++, is something called a pointer. Okay. So let me explain that real quick because it's worth knowing what that is. Because it still comes up even in the world of C Sharp and Java. We sort of have pointers, although you don't usually see them. So if I want to store an integer x, right? If I create a new variable, call it x, put number 5 in there, right? So there's some place in memory that's storing the number 5, right? So x is really an alias for the number, the memory address of where that is. Make sense? X really, once it gets compiled, x represents where is that 5 in memory. It's the address of it, okay? Now, so this is if I declare it type int. If I declare a variable that's type int pointer, which is what I put a little star on there. Now it's a pointer. Okay, now I'm still got a memory address here. But the difference with the pointer is I don't store it in the actual value in the variable. I store it somewhere else. So I'm going to say y is 6. I'm going to put the 6 over somewhere else in memory. Well, this place in memory has its own address, right? So I've got 3 addresses here. Where is x? Where is y? And where is y pointing to? Right? So let's say this is 72 here. This over here is address 72. So that's what things look like. Okay? So I've got a pointer that points over here. And I'm saying, I don't actually want to store the value here. I'm going to store it somewhere else. Okay? Anytime you create an object, whether it's in C# or Java, you're creating a pointer, effectively. Anytime you see the word new, you're creating a new thing. So if I have a string, the string's not actually stored here in this variable y. The string's actually stored somewhere else. Does that make sense? Anytime you have an object, the object's actually stored somewhere else in memory. Okay? Which also means that I can have another variable z here, which also points to an int. As long as it has the same address, they both point to the same 6. Does that make sense? So if I change this number to a 7, both x, both y, and z change. Does that make sense? I change it here. Now both of those two variables see the new value. Okay. So that happens anytime we have objects. Because what we have here, we don't call them, in Java and C#, we don't call them pointers, we call them references. Okay. And there's a little bit of difference about what a reference is versus a pointer. And the thing there is, so a pointer says, here's the memory address. A reference is a number into a table in your, what we call virtual machine. Okay, so in that virtual machine, in our case, it'll be the Java virtual machine. In C#, it's the, I forget what they call, the common language runtime is what they call their virtual machine. So in there, it keeps a track of where all the objects are. And it's like, okay, object number 5 is at address 152. So when we're storing a reference, we're actually storing the number into that table. That makes sense? But as far as we're concerned, pointer and references are pretty much the same thing. Okay. So here's the thing that you can do with that. You've got pointers. Well, when Java came along, they said, well, we'll have a lot of problems with pointers. A lot of problems with pointers. Gets a lot of programmers all confused and messed up, especially when we throw in weird things in C++ and C, like you could do double pointers. You could do int pointer pointer, which is a pointer to a pointer. So those kind of things, Java said, maybe we can write programs without pointers. So let's get rid of them. Okay. So Java came along in '96 and said, let's take all this stuff that we're doing and let's try to avoid a lot of the errors that people are having when they're writing C++ code. Does that make sense? They took a lot of features out to try and make the programming try and make things simple. But they also kept mostly the same syntax in a lot of ways to C++. There are definitely things that are different, but they tried to keep things in such a way that there would be the fewest speed bumps for people going from C++ to Java. Okay, so this is one of those things that they took out, right? But we'll still kind of see things manifest, especially as we're working with objects. Objects effectively are always pointers. Okay, so that's one thing you need to know about. They've also taken a few things out, like in C++, you could inherit from more than one class. When you're working with inheritance, you could have as many parents as you want. Well, that created problems. So in Java, we got down to just one class as your parent, and they added this idea of interfaces. So Java was actually the first one to introduce that idea. That's something that C# actually stole from Java, is the idea of an interface. So there's that kind of syntactic history. So Java was introduced in 1996, mostly based on C++, largely on the idea of let's take out all those things in the language that cause people problems. Okay? And the other thing that happens with C++ and C code, when you build it, when you compile it, you're compiling it against a particular processor because it gets turned into machine code, which then has to run on that processor. And you're also compiling it against a certain operating system. So anything we build with C++ and C, I can't take it from one operating system to another and have it run. Or I can't take it from one processor to another different kind of processor and have it run. I have to build a special version for every single processor. Does that make sense? Yeah. It runs faster because of that. But it means that you have to write a lot of different versions of programs. So if you see out there, there's downloads for things that have a 64-bit version and a 32-bit version. That means at some point there's some C++ still in there because it's still being compiled down to machine code. That's how that works. So Java introduced something we call the virtual machine, right? So you have your physical machine, right? The hardware that you're actually running on. We have a virtual machine. A virtual machine is in software, right? So rather than your program running directly on the hardware, it runs in this sort of interpreter called the virtual machine, which acts as an in-between layer. You can kind of think about it as an actual VM, right? If you've ever tried to run Linux or some other operating system inside of your own operating system, that's the kind of layer that we have there. So when we compile Java, right, we don't compile it down to machine code. We compile it down to something we call bytecode, which you may have heard before. Okay, anybody tell me what bytecode is? Hint, it's the same thing as it is in C#. Huh? Okay. So if I'm talking about machine code, okay, I'm talking about machine code. Everything in machine code is numbers. Once we get down to machine code, there's no characters anymore. It's always numbers.
It's in binary, right?
It's in binary, yes. So if I were to write an instruction and say add, I don't want to go through all of the details of what this is, AX and 5, add these two things together, that might come down to, hey, it's instruction 5, register 3, operand 5, and that kind of thing will be run on the hardware. And the hardware will figure out that 535 means add AX and 5. Does that make sense? So that's what we're looking at. What happens with bytecode is it's an interim, right? So it compiles into these numbers, looks like machine code, but they're actually numbers for this fake processor, basically. That makes sense? So there's a Java virtual machine. It acts as a kind of fake instruction set, a fake processor, if you will, right? So these numbers get turned into what the actual machine code is, right? So it might be 5 here in the machine code, but in the bytecode it's 7 or whatever. So the VM figures out what numbers in the bytecode correspond to the number on the processor, right? So as you're running Java programs, it's automatically compiling it from bytecode to machine code. So when you compile it, it only does part of the compilation. Does that make sense? It does part of the compilation when you compile it, and then the rest of it happens when it runs. Same thing happens when you're writing C# programs. You write part of the code, and when you hit the build button, it builds it part way, but it doesn't get built the full way until it actually runs. We call that just-in-time compilation. We compile it at the time you need it. Does that make sense? So we wait till we run it, and that's where it'll actually get compiled. Okay, so that was something that Java introduced. And the upside of that meant that a Java program, you could write one program and run it on any operating system or any processor. As long as they had a Java VM for their machine, a JVM, you could run your program anywhere.
So you can like run this on Mac?
Yep. So your Java programs could, in theory, run on Mac and Windows and Linux, and they'd all work the same. In fact, you could run your same program on there we go. Sorry, battery ran out of juice. So one of the questions that you were asking on the break is, while we were fixing that, is about, you were asking about null pointers or null references, right? So yes, if we're looking at pointers there, maximize this again. If we're looking at pointers, let's say I have another variable here, call it A, and it has the number 0 in there. Okay. If I've got the number 0 in there, that means it's what we call a null pointer. It's null. That means it doesn't point to anything. Does that make sense? So if I try to access, you see, if I try to access Z or Y, remember it's trying to access the value over here. So if in this case I'm not pointing anything, I try to access the value of A, that's where I get a null pointer exception. That makes sense? It's all okay until I try to get the value of it.
Is it not pointing to anything because of 0?
Because of 0.
Okay, make sure.
Yes. So 0 is the same as null. Does that make sense? Mm-hmm. A null pointer is the same as it's always set to 0. So it's either 0, which means it points to nothing, or it's a number which says here's where it is in memory. That make sense? Mm-hmm. So that's what you would see. If I tried to say what's the value of A or set the value of A, I couldn't do it because A doesn't point to anything. So, or if that was an object, I can get to the object because, again, there's no object. So with the virtual machine, that's the big thing that we saw introduced in Java. Okay, that idea of being able to run on different systems without recompiling your code. That's one thing that came in there. So one of the things that exists in the Java world is there's actually 3 different versions of Java that you do want to know a little bit about. So the first version of Java is called SE, or Standard Edition. Standard Edition runs on most things. It's designed to be run on desktops. So if you're writing in SE, SE is basically for writing desktop applications. Okay. There's also another version of Java called EE, or Enterprise Edition. So you got Standard Edition for desktops, Enterprise Edition for servers and websites and such. Make sense? So this is what you're going to run your website on, is Java EE. If you're going to run something on a mobile device, that runs through another version of Java called ME. which ME is actually was a bunch of different collections of, actually a few different versions of ME. Now, Java ME, notice that Java came out in 96. When did we get the first smartphone? When did the first iPhone come out?
7.
Huh?
Another like 2,000 blocks.
Let's say it's 2003, somewhere around there. It was in early 2000s. Okay. The iPhone never supported Java ME. None of our Android devices support Java ME. ME was actually all those previous phones, mobile phones, is what they used, is ME. So if you have an old flip phone back in the late 90s, early 2000s, it might have been running Java ME. Okay, but that's not Android. This one is effectively dead for the most part, because most of the devices that run it no longer are in the field. But early 2000s, late 90s, that was a thing. Even some of those devices were out in late 2000s, as they were. Not everybody had jumped in the smartphone world. BlackBerry would also have been running Java, for instance. So that exists there, and there's those different versions. As far as things are concerned, though, the only one of these you need to know about is Java SE, because that's what Android is based on. Android is based on Java SE. Okay, standard edition. So, 96, Java comes out. A few years after that, around 2002, Microsoft says, "Oh, this is a really cool thing, this Java idea. Why don't we make our own version of Java, but make it better?" Because one of the complaints about Java is Java programs take up a lot of memory and they're slow. So and it also, they took away so many features in Java from C++, a lot of people really liked. So Microsoft comes along in 2002 and says, well, we'll make our own version of Java. We'll call it C#, basically. And we'll add back some of those features that we really liked in C++. But we'll keep a lot of the ideas that Java did too, because those are cool. Like the virtual machine and the way they do classes and interfaces, and there's a lot of things that they decided to keep. So C# in many ways is kind of a descendant of both Java and C++, right? It has some things from C++ that don't exist in Java, and it has a lot of things that Java originally came up with are also in C#. So that being said, they are very similar languages. You've already seen C#, and Java are really, really close. There are several major important differences, but they're very, very close, which means that as we jump into this, you're going to see a lot of things that you just kind of recognize and you know how they work. Okay. Another important thing to know about Java. So originally when it came out, 1996, it was owned by Sun Microsystems. In 2010, Oracle bought Sun Microsystems. Oracle traditionally has been a database company, but they bought Sun at that point. Sun also had, you might have heard of MySQL. At that time, prior to 2010, MySQL was also owned by Sun. Sun was actually originally a chip manufacturer, is where they started. They originally made servers and hardware. But anyway, so they were bought out in 2010. So now if you go look up any of the Java documentation, it'll be on the Oracle website instead of the Sun website. That makes sense? So it used to be java.sun.com. It's now java.oracle.com is where all the documentation is. That was a big concern because historically Sun was really good about the open source community, and they really put a lot of things out there for free. You could basically use Java without paying Sun a dime. Whereas Oracle traditionally has been a company that produces things for very expensive corporate clients, where they're the license to buy a copy, buy a license to the Oracle database. You're talking hundreds of thousands of dollars or millions of dollars. They didn't play with any of the small players. So there was a lot of concern when that happened, and there is, in some ways, that has trickled down and affected Android in some ways. So that's something you need to know, is that because of that split, because of that switch of hands, it has affected Android. Okay. So that's where this kind of lands. This is the what we refer to as the C language family. There's a bunch of other languages. If you look on Wikipedia, there's a very long list of languages that are considered in the C family, but these are the ones you want to know about. And that's kind of where their history is. So looking at some of the history of Java. Again, we started in 1996. In 97, the next version of Java comes out, 1.1. In 1998, we then saw something called Java 1.2. Okay. Now, Java 1.2 is officially referred to as Java 2. So if you see that in the documentation, that's what that refers to. Java 2 is Java 1.2. Because historically, up until Java 5, all of the version numbers were 1.1, 1.2, 1.3, 1.4. They never changed the major version, that first number, until 5.0. Okay. Now, under the hood, other thing to know with 5.0, and from then on, a lot of these version numbers, a lot of the versions of Java actually have two version numbers. So in some places, you'll see Java 5 referred to as 1.5. In other places, you'll see Java referred to as 5. Okay, that goes all the way up to 13. So sometimes Java 13 is referred to 1.13 in some of the files, but it's also officially referred to as Java 13. So you may see that as you're kind of installing Java and getting some of the things set up. That's kind of the history of that. So Java 2 was kind of a big deal. It redid a lot of things for working with desktop applications, the way that GUI works. Changed a lot between 1.1 and 1.2. There were a lot of major changes there. But then things were pretty stagnant until 5.0. So 5.0 came out around 2004 and really shook up things in a lot of ways. The biggest thing that they added was generics, generics and collections. So you have seen generics. We have worked with them in C#, remember? So if you remember in C#, remember we had, let's say I wanted a list. I could say I wanted a list of strings. That's a generic type. Anytime you see those brackets like that, that's a generic type. So we're saying this is a list of strings. That was up until 5.0, that was not part of the Java standard. You could not do that. Anytime you created a list, it was a list of objects. So you had to downcast every time you wanted to use something in there. Meant there was a lot of casting in Java prior to 5.0. Okay, a lot of explicit casting. So they added that in 5.0, and that's changed a lot of things. You'll see a few things in even the quick reference. There's one section there where they talk about lists. I did put a note on there because it's still referring to the pre-5.0 world of array list. So that's one thing to be aware of. So in 5.0, that was introduced. Okay. 8.0, another really useful thing came in called the Stream API. Remember you used LINQ in last semester, working with C#, working with database. So Stream API is actually in a lot of ways very similar in terms of what it can do to the LINQ functions. They're all called different names. They've called them very different names, so it doesn't exactly translate. But the kind of things that you do with LINQ, are things you now do with the Stream API in Java. Okay,
So that's built into Java.
it's built into Java. Okay, so that was Java 14, Java 8, and that was in 2014 is when that came out. Okay, and now we're currently on Java 13 in 2019. Okay, so the two big things that you really need to know about, because those are what we're going to touch about on the semester, is the generics and collections in 2004 and the streams API in 2014. Those are the two big things that you need to know about. And the reason I want you to know what version they're from is because then in the year is so you have some idea to know, looking at the documentation or looking at textbooks and tutorials, were they before that time or after that time? Does that make sense? Because the tutorial that you read before that's older than 2004 is going to look very different than after 2004. A kind of bit of code that's been written for year to 2014 is probably going to look different after 2014. Okay. Now, Android. So we know Android applications are typically written in Java. There's actually another option nowadays called Kotlin. Kotlin is a relatively newer language, but it still compiles down to the same bytecode as Java. So any Kotlin code can also be run on the JVM. Makes sense? There's also another version of another language called Rubric, which also compiles down to the JVM. So in 2008, we got our first version of Android. Android 1.0 in 2008. Okay, and it ran on something called the Dalvik VM. So anytime you see Dalvik in your IDE, that's what it's talking about. It's that VM. Okay. And the Dalvik has now gone away effectively for newer devices. There's a new VM called the Android Runtime, or ART. But you still may see errors or bugs when you look at your logs that may say Dalvik, but they now refer to being ART. That's what they're talking about. If you see the words Dalvik or you see the words ART, they're referring to the Android virtual machine. Now, it's worth noting both of these virtual machines are not the same. They're not exactly identical to the virtual machine that runs on your desktop. They're not exactly equivalent to Java SE. There are some differences. Okay. Most of those are kind of a low level, so I won't really get into those, but you need to know that. Okay. Now, for reference, we're looking at 2008. First version of Android in 2008. When did I say that Oracle bought Sun? That's the first version of Java. 2010. So sometime after 2 years after the first Android phone, Oracle bought Java. Okay. A few years after that, Oracle sued Google for using their virtual machine code. Because the claim was that the whole thing about the court case was that they said, okay, here's the code for the Dalvik VM. Well, remember that when Sun was doing things, everything was just out there. They made that open source. So Google said, okay, well, we'll use some of the code that you have for your own virtual machine and write our virtual machine based on the virtual machine that was made public by Sun. Make sense? Oracle changed that rule, right, on them basically, and said, oh, you can't, for Android, you can't use any of our code. Oracle said, it's all ours. So effectively, that's the main reason why we have Android runtime now, is because Google had to go back and rebuild the virtual machine from scratch, or change a few things, and change a few things because of that whole court case. Yeah. That means that as far as Android is concerned and Java is concerned, Android, let's see, what's the most recent version of Android? Android 10 and Java 13 are not the same. There are features that are in Java 13 that are not in Android. And there are things in Android that are not in Java. So that is going to mean that there are some differences there, and you have to watch as you're looking at the documentation, recognize that they're not exactly the same. Okay? They both use the Java language, but they're two different versions of the Java language. Okay? So there may be some features that you read out there about this is available in Java. It might work for a desktop application, but not work for an Android application. Those syntactic things. Does that make sense?
Is there an example of something that's
Not that I can think of offhand. I ran into a elaborate article that explained a lot of that stuff in the past few weeks, and I don't know if I still have a link to that. If I do, I can share that. But there's a lot of kind of tricky little, a lot of it's syntactic sugar that was added to Java in kind of recent, but didn't necessarily make it to now. So historically, where Android kind of broke off from Java. Android broke off from Java at 5.0. So everything in 5.0 works in Java. All the things that are after 5.0 may or may not work on Android. Does that make sense? And historically, the other thing that means is different versions of phones, different versions of Android phones support different features in Java. Okay, so it's a question of whether or not, okay, that was introduced in this version of Java, what version of Android was it sort of, quote unquote, introduced in? Because the version is 5.0 of Android is not 5.0 of Java, etc. So that's what you need to know about there. Is that effectively there's two different versions of Java. There's the Android version and then there's the Java SE version. So looking at the version numbers for Android, we've talked about Java. Android, the latest version that's out there as of 2019 is version 10. Okay, so we have the first version 1.0 up in 2008. We have version number 10 in 2019. Every smartphone, every tablet that's out there that's running Android has a particular version of Android. And oftentimes those may be, when updates come to Android, they don't not immediately go out to all of the devices. So once there's a new version of Android, say 10.0, well, your actual smartphone manufacturer has to make a 10.0 version and then ship it out to all their devices. And typically they ship that out on a per model basis. So if you're having, say, a Samsung tablet, a Samsung Tab 3 is going to be all at a different maximum version number than a Samsung Tab 4 or a Samsung Tab 5, etc. Does that make sense? So your actual device will impose a cap of what can you upgrade to, because that's what the manufacturer has limited their version to. Does that make sense? It also means because there is updates, what version of Android it originally shipped on may not be the version you have. So one of the things you'll see with the tablets that we have, there might be slightly different point versions between the different tablets. Does that make sense? They're all they should be close enough, but it may be that some of them are 5.0 and some of them are 5.1. Which means you're targeting a slightly different version of Android. The way I set up the assignments, it will be on the minimum version everybody has, the smallest version.
So why are the code names all like they're related?
Yeah, almost. Yeah. So that's a great question. So historically, yes, they've had the actual version numbers, which these ones do matter, and this is what you'll see in the documentation. But they've also had code names for them. Now, those code names were invented before it was actually released as an official release. Does that make sense? So as they're building it, but they officially haven't decided when it's going to be released, this is called Marshmallow. and Lollipop and Kit Kat. So they've historically, yes, been food items been the code names for different versions of Android. It's been a big joke. I think at some point Google had a statue of a Kit Kat bar out in front of their offices, and different things like that. So there's things in there. There's a lot of Easter eggs that you'll find in Android related to those different foods. But yeah. So nougat, marshmallow, Oreo, pie, all of those kind of things.
Ice cream sandwich specifically, and not for the ice cream sandwich, right? Specifically the same.
Also, I was thinking that Kit Kat is trademarked.
Yeah, that's the weird one in this list.
And Oreo.
I think the two, Oreo, Kit Kat, and Froyo are all kind of brand marks, but the rest of those are generic words. That may have been somewhat an influence on it, but apparently they talked to Kit Kat. Kit Kat was like, yeah, totally, you can use our name. And apparently gave them Kit Kat bars. Anyway, so that's the version numbers. You will see as we were actually working with Java, when you're working with Android code, sometimes you will see all three of these numbers. So depending on where you're looking, like if you look at the Android, there's a way on the system to see what version of Android your device is running. That will show you this number. When you're doing comparisons to say this device is this version or later, those constants actually use these names. So if you're saying I want to check is this version Kit Kat or later, you'll actually have a constant called Kit Kat. You say is this version number greater than or equal to Kit Kat? So you will see that, and that's why those do matter, because you'll sometimes see those end up in your code. The most important thing, though, to pay attention actually is these numbers, the API levels. Okay, the API levels are really the version numbers that you use in code, and this is what we'll see in the IDE. And this is really what we want to go back to is the API level. Okay, so the API level, that says what version of Android are you really running, and what version of the API are you running against. So anytime the Android has a big change in the language, where they make a breaking change or they add something big, you'll see a change in this API level. So for instance, look at Froyo. Notice 2.2 and 3.3 all have API level 8, right? So that means that there were changes in the Android operating systems, but none of them affected the code, right? So 2.1, sorry, 2.2, 0.1, 0.2, 0.3, all of those were effectively the same thing as far as the code's concerned. And then things happened, something in 2.3 happened that would have broken previous code. So that's usually what we go by. And when we build our applications, we say, this program can work at a minimum at this API level, or at a maximum at that API level. So we give, anytime we build an Android application, we say, from this API level to that API level. So we're going to target it towards this one, but it can run at most on this availability device. Because at some point we have to say a limit of like, it can't run on devices this old because that's just too many compatibility issues to deal with. So the line where we draw that demarcation at the moment, at least where we do it last semester, was around API 16. So that's where you kind of get 99% of the market is 16 to 18. That is kind of the deal. Does that make sense? So what you'll see with that is if we're writing an Android app, we're supporting 16 through 21. So a lot of different versions of Android.
Right around the yellow.
Huh?
Right around the yellow.
I think that the tablets that we have are Lollipop. Lollipop or Marshmallow. I have to go back and look at them again. But I think the Tab A's that I have that we just got are Lollipop and Marshmallow. The tab 4s that I have are KitKat. So I've got Lollipop is probably what we'll be targeting this semester. But I think if you boot up a new project in Android Studio, if I remember right, it still defaults it to the minimum being 16. So that's that kind of version history. So you've got a kind of broad overview of like, here's C to Java, and here's some of the different versions of Java. Here's some of the history of Android. So let's look at actually our first application. So writing an application in Java, everything you write has to be in a class. There's no such thing as functions that float outside of classes. And actually, when Java was introduced, that was a new thing because both C and C++ allowed you to have functions that weren't in classes. So that was something that Java changed. It said, well, we're going to be entirely object-oriented, so every function you write now has to be in a class. And C# has stuck with that as well. So in C#, you also can't write functions outside of objects. So when I write my class, public class hello world, looks kind of almost identical to C#. Same syntax. So public says that this class can be used anywhere in the program. Class says it's a class. Hello world is the name of this class. Simple as that. One rule in Java that's different than C#. In Java, the name of your class has to be the name of your file, as long as it's marked public. So if it's not marked public, you can call it something else. But typically, you only want to have one class per file, and that means that your file name needs to be the same as your class name. So if this is hello world, this is going to be in a file called helloworld.java. That's the extension. So remember C#, it was helloworld.cs for C#. Java, it's .java. So all of the code files that we have this semester are basically going to be .java with some additional XML stuff when we get to Android. So we'll have XML files and we'll have Java files. Okay. So the outside layer there, we've got a class. Inside of that, we've got a special little function called main. Okay. So in kind of C fashion, C++ fashion, the way you read Java and C# code is kind of in a spiral. You start in the middle and then you go around and you go around until you get to the outside. So the place where you want to start by reading the method signature is here, the name of the method. So the name of the method is main. Okay. The next thing we can look at is what does it return? It doesn't return anything, it's void. Same way that it works in C#. And in fact, that's been the same way since C. Void has been, I don't return anything. So it returns a void. It takes a parameter called args, and that parameter args is an array of strings. What that's for, this is for if you're writing, this is for console applications. So if I start up a console application, I can type in a series of arguments on the actual command line, and that's what will end up in that array of args, is those command line arguments. Okay? And when you write them in on the console, they're separated by spaces. So I might run, say, run program A, B, C, and then I would get A, B, and C in that array. So that's what that is. That's for command line args. We will not do anything with that args array this semester. I can tell you that much. Because once we get to Android, we're not going to write a main function anymore. We'll be writing a main function for this first 2 weeks. After that, we won't write it at all. Okay? But you'll need to have a main function in every program you write for this first 2 weeks, basically. So, because that's where, when you tell the program to run, it goes and runs main. That being said, even though we're not using the array of args, it has to be there. Because when it starts to run your program, it looks for something with specifically this signature. It looks for a class that has a method named main that takes an array of strings and returns void. If it doesn't follow that exact signature, when you try to, it will compile just fine, When you try to run it, it will say, I can't find a main method. That make sense? So you need to remember to put it in there, even though we're not doing anything. Okay. We also have some different keywords here. We've got public and we've got static. Public again means we can call this method from anyone. Public needs to be on your main method, but public means you can call this method from anyone. Static. Anybody remember what static does?
Keeps it the same, or like every instance of the class will share it. So if it was, say, a variable, if you set it at like 30 in one instance, it will be 30 in all of them.
Yes. Yes. So if I have a static variable, then I really only have one instance of that. I don't have,
Even if you have multiple instances of the class.
even if I have multiple objects,
Yeah.
I only have one instance. That we call that a class variable. Okay. So similar, we call this a class method. If it's marked static, it's a class method. If it's a variable, then it's static. That means there is only one copy of this in memory. Okay, that's one thing it means. It means a few other things.
You don't have to instantiate it. You just say hello world operations.
So I'm going to take one issue there. Instantiate it. What do I need to instantiate? Are we talking about instantiating the main method? The hello world class, right? So I don't need an instance of hello world to call main.
Right.
Why is that important in this context?
Because when your system tries to run a Java program, it's looking for this main method
Right.
inherently, and it has.
You haven't created any objects yet.
Yeah.
So if this wasn't marked static, you would have to create the hello world object and then call main on it.
Mm-hmm.
But the problem is then it has to call the constructor before it calls main, and who knows if it can do that. Huh?
It's a circular issue. It
Yeah.
can't run main if there isn't a class, and if there isn't a class, it can't run main.
Right. So yeah. So that's why we do static, is because it starts at the beginning when there's nothing created. So that's why that's static, is it means that it's that. It also, the other thing with static is with inheritance. Static methods are not inherited, if that makes sense. Right? So normal methods, I can override them in a subclass and change their behavior, but I can't override and change the behavior of a static method. Does that make sense? And that would be a problem if I have, okay, all of these classes have a different version of main, right? Because I need one main to start the program. Does that make sense? So that's what that means. So we've got our main method. In there is the code that's going to run when the program starts. Okay. So what I want to do when the program starts, classic hello world, is just print hello world to the screen. Okay. So you can kind of see in double quotes here. I have that hello world string. That's what I want to print. Just like C#, any strings that I want, I have to delineate any of those string contents, string literals, I have to denote with double quotes. Okay, so double quotes means I have a string. Now, this is the convoluted way that we print things out. So system.out.print line. This is an L, not an I, by the way, or a 1. It's print L. Okay, so that stands for print line. Okay. What you're seeing here, and let's walk through this in 1 minute, but this is what you'll need to remember, because anything you want to write out any output to the console, as far as writing console applications, that's the method you need to call. Okay? So system is a class, and it lives in the namespace or the package called java.lang. Okay? Now in Java, any package in Java.lang, any class that's in Java.lang is automatically brought in. I don't have to have any sort of like using statement up top to say where is the system class. Okay, so it's automatically brought. So, but if I was going to fully write this out, this would be java.lang.system. So in Java, if you see an uppercase letter, that means it's a class. So I know this is a class simply because it starts with an uppercase letter. Okay? So system is a class. Out is not a class because it doesn't start with an uppercase letter. So it's something else. If it doesn't start with an uppercase letter, it's something other than a class. Okay, so out is a static member variable of the system. It's a class variable. Okay? So out is the standard output stream where we write things. So if I write something to out, that's going to go to the console. Does that make sense? It's going to go to what we call standard out. It is what we call an out stream. So that's what class it actually wants. So if you're looking for the documentation for this out object here, look up the out stream class because, or sorry, print string, because it's a copy of, it's an instance of print string. So print line says take the string that I have and write it out to that string. That makes sense? So that's what's that. There's also another version, just print. Print will write it out to the output, but will not add a line terminator. So if I write print 3 times, it all will end up on the same line. Versus print line terminates the line. As a general rule, use print line most of the time. There's another one in there called printf, and we'll definitely want to look at that one. But printf is the way to write formatted text. So it's got an interesting sort of syntax that we use for printf. It's the same one as in C++, but it's a very different one than what's in C#. So what you're used to writing for string formatting in C# won't work here. There is a string.format method that works in format strings, but the way we write that is very different in Java. So we need to look at how we format strings. But just note that the Java formatting specifiers and the C# specifiers are very different. In many ways, C# is definitely superior, the way they do their formatting, because they had a chance to scrap it all and think about it from scratch, versus Java said, well, we'll just take the version that was used in C++. And actually, it was really invented in C. So the way you write format specifiers in Java is the same way that it was in C.
Can you do like still format like
Currency, no. You can't do currency. You can do numbers. So let's look at that real quick, because that's a good question to talk about. So let's say I have let's say I have in C#, here's my program, x equals 5, float, y is 3.2. Okay, so I've got 2 different variables there, one that's an integer, one that's a float. If I want to write those out in C#, I'm going to write console dot write line and that would look like so. So let's say I want to print out both x and y. So this is going to be 0, and I'll put a comma between them. So, and then 1, and I want to round this to 1 decimal place. So I'm going to say F1. And then I would write x comma y. So that would be how I would write it out in C#. Okay. So in Java, do the same thing. The first 2 lines are the same. So x is 5, And actually, because that's a float, that would actually be an F there. 3.2 F. Reason being, remember that by default those constants are doubles. I want to say specifically with their floats. So here I would say system dot out dot printf, and what's going to change, so there's a few things. First of all, this adds a line terminator, this one doesn't. The way I write that first argument is what changes though. So in Java, the syntax we do, instead of using curly braces to delineate the start and end of a format specifier, I use just a percent to put the start of it. I don't actually delineate the end of it. So the start of that one, well, this is, what data type is this? In C#, they did a nice thing, and we don't have to know the data type. We can just say, well, it's a thing. I just say 0. Just give me the first thing and print it out. But in here, I need to know what data type I'm writing out. Okay, so I've got an int. Okay, because the format specifier I use for integers is different than the ones for floats. Okay, so when we're writing out an integer, we use D. Okay, %D. D standing for digit. Okay, but D is integers. Okay, I'm going to write a comma, and I'm going to write another %. Any guess as to what format specifier I'm going to use for a float?
D.
Nope.
Was it N?
It's F. So D for the integers, F for floats.
N is decimal.
So it's going to be D for digit for any integers, whether it's a byte, short, int, long, whatever type you're doing. If it's an integer, it's a D. If it's a double or float, it's F. So floating point or integer.
N
Okay.
for decimal.
And then
so
X, Y. Huh?
is N still decimal?
These are the only two we use, D and F. Okay, so D is integer, F is float, S is string.
Okay, good.
Huh? Remember, this syntax is the same one that was used in C. So ask Bjorn Storstrup, who originally created C, why he used D. I don't know.
Does the decimal data type still exist? Okay.
It was still called int. Back in C, it was still called int. So why they use that one, I don't know. So this would be kind of the way you do that. Now, if I just leave it as this is %F, it's going to write out an arbitrary number of decimals after the decimal point. It goes up until it gets to a 0, or the upper limit of like 8 digits. So if I want to specify how many digits I want, I actually need to specify that. So the way I'm going to do that is I'm going to do dot 1F. So the dot says after, this is for after the decimal points, and then the number after that says how many decimal points are around. So if I say dot 1, I'm rounding 1 decimal place, dot 2, 2 decimal places, dot 3, etc. Does that make sense? You can see where this is very different from that. Very, very different. This is hands down easier to read. Again, that's hands down easier to read than this. But that's the syntax we're going to have to use in Java. Now, I want to add a line terminator at the end. So I have 2 ways I can do that. I can either call print line after, or I could add a /n over there. But typically, that's the one that I would go with. Print line. If I do that, this is equivalent to that. Those 2 programs are the same.
Couldn't you add like a /n?
Yeah, I could. instead of doing this, I could put /n at the end here. That, however, only works on, it depends on what operating system you're running in. So in Linux, you typically use /n. In Windows, you typically use /n/r. Okay, so if I do that, it may not work on all operating systems. If I write print line here, it works on all operating systems because it automatically figures out what the line terminator is. So if I use this, it will automatically figure that out, line terminator, versus it being operating system dependent. Does that help as far as printing goes? To kind of see some of the format specifiers? That's one of those things that you'll really definitely want to read the documentation on, because there's a lot of nuance and there's a lot more here than I've told you about. But this is what you need to know most of the time. That's usually good enough. Okay. So let's take this Hello World program and let's actually get it to run. So this won't work on your system right now because you haven't installed all the software that you need. So don't code along because it won't work. But what I'm going to do is I'm going to create a file and put Java in it. So the way you create that, if you say new text file, you're going to get a new text document. I could say my class. The trick is I need to change that extension to .java. Okay. Now, one thing you do want to do on your machine, if you haven't done this yet, if you have a file, if you have a folder open, your File Explorer, go to View tab and make sure that you have file name extensions checked. If you don't have that checked, these may go away. Let me see. If you've right now they're not going away because it doesn't know what program to open them with. But once I open them up, see, it's going to ask me which application to use. I'm going to tell it to use Notepad, and now the extensions aren't there. So if I'm looking at like this, well, this looks, I just in my class. I don't see the .java. This is Hello World. It doesn't look like it has an extension. That's important because in a second here, I'm going to have files with the same name but a different extension. So I'm going to have .class files and I'm going to have .java files. So make sure that you have file name extensions visible. Okay. So I want to have my file name extensions visible so I can see these are .java files. If I open this up now in Notepad++, you can kind of see that it starts out as blank. So I'm going to go ahead and start putting that code in here. So I've got hello world.java, which has got all of that code in there. Okay. So you can see it's really just a text file. Right? I've got it open in Notepad++. This is in fact me doing it without any sort of IDE. I would definitely recommend doing an IDE, and the one that I've given you install instructions for is IntelliJ IDEA. That's the one I want you to use because it's basically the same as Android Studio, which we'll be using in the next few weeks. So that way you can get familiar with the IDE and it will translate over when we go to Android apps. But you can write applications without having any sort of IDE. You just have to have the Java Development Kit or the JDK installed. And the other thing that I've done is I've gone ahead and added the JDK to my path variable, which means I can get to it from anywhere. So assuming I've done that, I can right click in here and I'll get a console prompt out. Okay. Now the way I get that console prompt, if I right click in here, notice you don't see an option to open a console. I do have a get bash here, but there's no option to open a console. So if I hold the shift key when I right click, you see there's an extra option there. You hold the shift key and right click, it says open PowerShell window here. That's a thing. It's been a thing in Windows for a long time. A lot of people don't know about it. So if you hold the shift key down while you right click in a folder, you get an additional option to open PowerShell here. So I'm going to open up PowerShell here. You can see that it's what folder it's running in. It's running in this Hello World folder. If I normally had opened PowerShell, it would be like in the Windows folder. It wouldn't be where I want it to be, so I'd have to go here.
So glad you showed me that.
Yeah, saves a lot of time. So if you shift right click, you'll get a console prompt right there. Okay. Now, the command I want to write and use is called Java or Java compiler, Java C. So Java C, and I'm going to compile the Hello World file. Now, one important thing here, I do need to make sure I include the extension. If I forget the extension, the .java, I'm going to get an error like this. It says only accepts annotation processing, blah, 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 blah. So I need actually, what it's effectively telling me is I need to have the extension there. So it's not just the file name there, you have to, not just the first part of the file name, you have to make sure you include the full file name if you're using Java C. So I'm going to say Java C, Java compiler, hello world.java. Okay, that's now compiled it. There's no output, so it's successful. And you can see that there's a .class file here now. So I have the hello world.java, which is the class, which is the source code that I wrote, and the .class, that is the bytecode. That is the bytecode file. In fact, if I try to open this up, let's take a real quick look at what that looks like in Notepad. It's just noise, right? Because it's now a binary file, right? It's now, these numbers represent the instructions to the virtual machine to run, okay? So I can't just look at that and read it. Although, if you're interested in doing things nefarious, there's still enough information in here potentially to figure out what was going on and to do some nefarious things. So don't assume that your code is now encrypted. It's not. It's very easy to take this bytecode file and reverse engineer it back to your Java code file. It's very, very easy. And I can see, so if I had like passwords in there, well, hello world is pretty easy to see in there. So don't treat that as an encrypted or secret kind of file. So we've got the bytecode. Now we've got the bytecode, we want to actually run it. Now, class files, I can't just double click and tell them to run. You can't do that with Java class files. I can't double click them and run them like programs. I'm sorry. So the way I run those class files, the way I run these console applications, I have to do it over the console. So Java C is how you build it. Java is how you run it. So we're going to say hello world.java, and here I'm going to write hello world. No extension. So when I compile it, I have to say .java. When I run it, I don't give it that extension of .class. I just say hello. I just say Java, hello world. That's all I have to do to run it. So you compile it, and then you run it.
So that second command is going to the .class version.
Mm-hmm. Yeah. So if I were to delete the class, see, no class there. I'm going to try and run it again. See, cannot find the main class. I cannot find the hello world class.
So what it's basically doing is it's just like searching through that folder to find that .class file, right?
Yeah, yeah, exactly.
So when you ran that Java C, that's what created.
Yep. So Java C built my code and turned it into a class file, and then when I run Java, that runs the class file. So build my bytecode and then run my bytecode. Okay. Now, when you pull this up into an IDE, it will take care of a lot of these things for you. So once you're running in IntelliJ, you will just hit run and it'll do both of those steps for you. Just nice. But that's what you need to understand that is going on. So any errors that I have, so let's say I go to my code. And let's say I forget a semicolon, because every line in Java also has to end in a semicolon. Say I save that. Let's try to build this. Well, I'm going to get some errors, right? These are what we call compile time errors, right? They're generated at compile time. So it's going to say, oh, we expected a semicolon. So when you run Java C, that's where you may see some errors. It may tell you where you have a problem with your code.
Soon will be.
Mhm. Yeah, agreed. So into 2 minutes, let's see where we're at. So that's the code for my Hello World program, most of which you've seen. The only new thing here really between C# and Java is the system.out print line. Okay, and the way you have to write the main method. And then that's how I'm going to go about actually running it. Use Java C to compile it, use Java to run it. Yeah, so let's go ahead and take a break here, and we'll finish up the last few bits that I've got here because I want to talk about the documentation that's out there and available for Java. Come back at 3:10. So as you're writing Java code, you're going to want to familiarize yourself with all of the classes that exist in Java. And specifically, you want to be most familiar with the classes that you're going to be using on a regular basis. Now, the way to get to that documentation, I've provided here on this side, there's a direct link to the API documentation for Java, SE13, as well as the documentation here for the Android API. But let me show you how you can find those yourself, assuming you don't have those direct links. So if you go to Google, what you're going to type in is Java API docs. Now, if you just type in Java API docs, look at what the first result is. It's 7, right? Which 7 isn't going to have all the classes. It's going to be missing some classes. So I want to make sure that I'm getting the proper version. So in this case, I want version 13. So I'm going to add to the end of that, I'm going to look for Java API docs 13. And once I do that, I will get here. There's the Java API, the 13 docs. Okay. Now, good thing to know, there historically has been 2 different versions of these documentation. Let's see, can I get it to show up on here? Historically, there's been 2 different versions of the documentation. It's not currently here on the latest version because the feature that it uses is going away in modern browsers. It's actually being deprecated. So historically, the Java documentation used what's called a frame set, which is actually a predecessor to the iframe. But that is a different way of looking at the documentation. So let's say I go to an older version of the docs. Let's say I go to Java 8. Okay. And get back into the API documentation. Or maybe I just need to go back to Google and rather than force it. Let's go to 8. So historically, the Java docs have looked like this. Historically, the Java docs have looked like this, where you've got 3 different panels. So the first top left one is your list of packages or namespaces. So a package is a group of classes. You've got all the classes in Java here, which is a very, very long list. Those are all the classes that are currently that we're in. This is just Java 8. And then here you've got the main view where you're going to look at the information. So if you're looking at an older version of the API docs, they have these 2 options here. So this is the frames version, and there's also the no frames version. If you're looking at no frames, it's going to look like this, where it's just all one page. If you're looking at the frames version, that's going to be this. So that's what you're going to see. But the newer documentation, that's been removed. Unfortunately, that makes the API documentation a lot harder to navigate because historically, this is kind of your nav bar over here to get from one class to the other. So that used to be how you would find classes. Nowadays, you're going to use the search bar. So go look here. Let's say I want to find the string class. I'm going to type in string and see a little Ajax happening. I'm going to go to java.lang.string. So this page is going to tell me everything I ever wanted to know about the string class. Okay, so the first part up here, it tells me what package is it in. It's in the Java lang package. So if I wanted to import this class, I would say java.lang.string, right? But Java lang's imported by default. So there'll be a lot of classes that are, for instance, in the java.util package that are really, really useful, but you have to import those explicitly. Okay, so we want to know the package, the name of the class. You can also see in here what are its parent classes. So this is kind of a hierarchy. So we can see that string is a subclass of object. If I looked at some of these other classes, I could see a further more layers. Okay, we can also see all the interfaces that it implements and all those kind of pieces. So if I go down here, all of the classes in Java have this big header section that tells you a whole lot about that class. And this is one of those places where Java is really, really strong, is there's a lot of documentation here. Whereas C#, it's not unusual to get like a sentence or two on some of these headers. These are usually pretty big blocks of text, and they're usually worth reading, especially if you've never used that class before. It usually gives you what you need to get up and running with that class. Okay, so definitely look at those. Once you scroll down further, you'll see a few different categories. You'll see fields or member variables. Namely, you see that there's a constant here. You'll see your constructors, so you can see all the different overloaded constructors that the string class has. But you can also see all the methods. This is where the most important stuff is. So we can look at all of the methods in the string class. See that? A lot of stuff. Huh? There are static methods in there too. So let's see, where is one that's static? I think, let's see, split is static. Oh, no, split is not static. Oh, there it is. So if it's static, you'll see the word static over here. So this first column is the return type, and you'll also see any additional things like static there. So you've got the return type, the name of the method, and what parameters it takes. So for instance, you see there's all these different value of methods. And if I click on the method, so let's say I go to string split. String split, there's string split. So if I go to the split method, I can see it's going to tell me how that method works. So there's an awful lot of documentation on all the methods, on nearly all the methods in Java, and this is really, really helpful because it'll tell you what are the parameters, what do they do, what does it return, what are the conditions for that return. So I definitely advise taking a really close look at all that stuff. There's also a section for some of these called throws, which will tell you what kind of exceptions it can throw. So you know what to catch. So there's all those different pieces in there. There's also a nice little number here, since 1.4. So you can see what version of Java that was introduced in. Okay, so that's good to know. And there's some related things like that. Or this one was introduced in version 1.5. Right? So this is a very good place to start your kind of search and reading up as you're writing Java applications. Definitely refer to these API docs. That being said, remember what I said earlier about Java for SE is not the same thing as Java for Android. So these docs are all fine and great when you're just working with Java. Once we get to working with Android, you'll actually want to look at the Android API docs, okay, which are very similar, but there are some differences. So if you look in Google, you're going to look for Android SDK docs, or Android API docs.
Android software development is the process by which new applications are created for devices running the Android operating system.
I get her to stop. So Android API docs is what I want to look for. There we go. So you'll get to this page called API reference. And if I look into Android platform, there we go. So this is very similar to the Java API docs, but this is specific to Android. So I can see the list of all the packages. I can look for a specific class. So if I want to get the full list of classes, I can go here. This is a very long list, so it may take a minute to load. If I want to look for string, I'm going to go down and look for string up here. There's the string class. So in a similar sort of fashion, I can see the name of the class. I can see its hierarchy. So string is a subclass of object. Same kind of header here about what is that class. And I can go down and look at all the different constructors and all the different methods. Again, this is where we'll spend a lot of time looking at different classes and looking at how they work or looking at different methods. So definitely take your time and read up on some of these because you'll need them as you're working through your lab work. Does that make sense? Okay. Yeah, this one is, the SDK docs are quite a bit newer. They weren't designed with frames in mind. So I definitely say they're a lot smoother. Once we get to Android, this is basically where we'll live, is in the SDK docs, just because there's a lot of information there. I will say that Google has not done as good of a job documenting Android as Sun did documenting Java. So the documentation for classes that are in Java is definitely a lot better for the ones than the ones that are in Android. But that's how you get to those things. So you will definitely want to refer to that. I have compiled a list of the most commonly used classes with links. So you will find that if you look into perusal, I've uploaded this document to perusal. But there's a link to the API docs and all the common classes. These are the ones, if you're going to read any classes in the Java docs, start here. Here's the basic classes that we use all the time: system, scanner, string, string builder, character integer, yada yada. These classes we use all the time. There's a few more here for collections, working with arrays and lists and such. And then hash maps as well, and then there's the new Stream API. Those are other good places to look as well. So as you're perusing the rather large set of classes, focus on those, because those will solve 99% of the problems that you're going to have at this point. All good? Because otherwise it's easy to get lost in the giant docs. There's just so much there. But those are the classes that you're most interested in. Okay. At this point, I want to make sure that everybody gets into the GitHub Classroom. So if you would, follow that invite link that I have here. And that way you'll get your GitHub repo set up and going.
I was looking on the setup, the stuff, and there was one for the environment variable. That doesn't exist in my.
Yeah, you'll need to create.
Okay, is that a system or a user?
Create it as a user variable. You can actually create it as either. Remember, system variables are the entire system, every user on the system.
Right.
User is just your specific user.
Okay.
The difference is if you put it in the user, you don't have to reboot the machine. If you do it as system, then you do have to reboot the machine for it to apply. And then the user always takes precedence over the
Okay.
So I would just put it in as user, but you can technically put it as either.
Especially if it's a personal laptop, so there's no need.
Yeah, there's no difference here. You just put it in as user.
Right.
Which is why I clarify. see that it says you accepted it, and your repository's been created, so you got a link here. You want to follow that link.
Yeah, it is.
Oh. That's interesting.
I didn't error.
Yeah, okay, let me fix that.
Apparently some of the files that I uploaded were too big. So let me go fix the repo, and let's try that again. So if I go here, it might be. Yeah. Yeah. It's definitely PDFs. So if I delete the biggest ones,
Stack Overflow notes.
yep. Okay. Sorry, that is not an error I've run into before. Okay. Essen, you want to see if you can clone that again? Follow the invite link. I may have to change something on the assignment on the GitHub side.
Did you do all the startup stuff, Brad? Did you do all the setup stuff? Yes. Did you have to, like download that CPA separately? Did you do it through Android Studio? Like this part?
You have to do it through Android Studio. If you download it separately, you'll put it in a different folder, and you'll end up with 2 copies.
So do I have to make a project to use that side though? Because
Yeah, you have to create like
a dummy project.
No.
Because that's what
It's down on the bottom of your configuration.
SDK.
Yeah. But no, you can't. If you download it separately, it'll download to a different folder,
So you said
and you'll have to download it again.
So the ones that we have are lollipop, but then you think maybe there's marshmallow as well, and then your eggs.
Yeah, what I would start with for now is I'll check when I give out before I give all the tablets back. I'll find out what the minimum version is, so I know which version we're using. But it'll probably be API 16. Somewhere between 16 and 19 will be our minimum. So.
Oh, so that's okay. Because just on the document you had it as. Yeah, it's on a 21 on the document.
Oh, okay. As far as which ones install.
Right. Yeah.
Yeah, just follow that then, because I must have checked already.
Okay.
Oh, okay. I didn't update it for the tab A's. Yeah, just do 5.5 and 5.1 at the moment.
Cool.
They're pretty large, so you don't want to install a lot of them. They take up a few gigs easily, those different SK platforms. What assignment settings? Oh, I know what I need to do. I need to go to github.com. I need to say new, no template, 112 base. So we can get that clone fixed. Okay, so I'm going to try and fix the GitHub repo so you can actually get that cloned. But the thing I want you to do for kind of the rest of the day is get your device set up. So you can follow the instructions. They're under coursework for getting your development environment set up. You'll want to walk through that. Important note on there, make sure that you follow them in exactly the order that's given. Don't skip. Don't assume that you've already done something. Do it from top to bottom, because there are a few things along the way. If you do them out of order, you're going to have problems down the line. So make sure you do everything in order. Don't try to install two things at once. Just do one thing and then the next thing and then the next thing. You'll create more problems if you try to install more than one thing at the same time. So walk through that. I'll let you know when I have this GitHub problem sorted. Okay, so that cloned successfully, which means I need to go back. Install it again. Yeah, even if you've installed it previously, go ahead and install it again. Because, like, for instance, for the Git stuff, that will go through and do an update if you install the new version. All right, Alex, would you try that link and see if it works for you?
I haven't posted yet, but I just changed that.
Yep.
You download the 13, right? That's 11. So that's yeah, and then you got all five.
Huge grip.
Yeah, it worked.
Okay. Yeah, so the invite link, I ended up having to create a new assignment to fix the problem with cloning it. So there's the new invite link. What's changed is this part at the end. It's a new code. But you'll have to follow the new invite link to get the repo set up.
It's just on screen. Where are you looking at? Up to the top. .com/A for assignment.
Is that action underscore
Yeah, so RBD_CY. Yep, there it goes. Yeah, you go ahead and install the driver, but you won't install. Yeah, this stuff you won't be able to do until you have a device. So yeah, there's some stuff on the last page of that. I think that's the last page. There's some stuff on the last page that you have to do once you have it.
Are we doing that like next week?
This week, probably actually use it until the Christmas. I got Spider-Man. Like, we did. Really. Yeah, so you want to clone that down just as you're familiar with. I would recommend cloning it into not necessarily your desktop, Pulling it into another folder that's closer to the record. You might need to see projects folder to do what I do. I put it on the drive, but you try to do projects. Because sometimes it apps get kind of long, and by pulling it here, it's not
Well, it's not a crisis.
the same as last year.
Let's see, let's see the
So if you have that one set up, it should still be. Want to just verify that it's still registered.
Oh, I guess you probably copy that.
Plan is for tomorrow. We'll go over the basic efforts. We'll kind of start that. Tomorrow, as far as things to work on your own time, I would definitely start work on the Code Academy tutorial for Java. Start on that as well as everything else. So I definitely would that'd be your homework for tonight is to start on that.
Is Code Academy save progress? I forget.
Yeah,
So we don't have to worry about taking screenshots or anything.
No, it's a little log in.
Oh, right. I was thinking WD.
I do need to see it when we're done.
Mm-hmm. That's at the end of this week, or is that like later?
You'll get that. I remember it's on the inside right now.
Thursday?
Thursday.
What was the question? Painter? I had never heard of Painter. Huh. Yeah, it was unbolted.
The job on that is used by Android Studio. Mostly I use to kind of figure out what you really want to do. Have you changed your username on GitHub? Because I think last I checked, yours was still in your instead of being your name. Yeah, it still is. You see it created the repo as that name. Yeah, change it now, we won't change the repo. So,
Rose. Yeah. I still have cookies on this thing.
we can install that. Because we see it's part of the Can you change the
Can your repository be renamed?
Did you change it?
Yeah.
Okay, go back to the repository. So I'll just right click on that and go back to it. So go to edit on the right settings, actually. And that's where you want to choose. It should be Alex.
Okay.
So turn right now. It won't show up under your returns, and because the phones up, it makes it harder to directly get the phone. So, here's one. Merge. That should be last one. That was last semester. Yeah, because that one's that's the that your semester your fourth you think from one semester and see that double check your check. You have what? I'm not. Oh. Oh, yeah, that. Put them in the invitation. It's not permission to do that. That was supposed to be created. Yeah, it's good. That was supposed to add you to the repo you just put in. Okay, so Ben, the repo did get created. I can see it here, but it's private, so somehow, what that means, somehow it got created, but you didn't get added to it. So if I add you here,